Good morning and thanks for joining. My name is Nishant. I head up what we call as engagement practices at Ericsson India. And thanks for giving us the opportunity today to talk to you guys about India and how we see the indoor marketplace growing for cellular mobility. What I will talk through today is basically why is indoor important, what change in landscape has made it more important in the recent years, what is the best possible way to address it, what are the impediments in addressing it the way we address it today, and what are the solutions we have to actually go ahead and capture this new market that is coming up. While we do that, of course, I'll run through a few slides. I will also run through a few animations as we talk as well. And please reserve your questions, and I'm happy to answer them towards the end of the webinar. So I'll start with the slide which says, there is a major shift. There is a major shift for greater connectivity in India, and of course, this is a statement that I'm making that is not, new to most of you. We're seeing a very, very rapid increase of take-up of mobile data in India. This is evident from not only continuing to increase mobile subscriptions. We saw 13 million increase in Q3 alone, which was, by the way, the highest number in the world across countries. We're also seeing that the smartphone penetration is going up very significantly, and the traffic per smartphone going up equally fast. In India today, an average user typically uses their smartphone for 3 hours a day. And as you will see on the slide, the mobile traffic, the number of subscriptions, smartphone subscriptions, they go up from 130 million to 750 million by 2020. Those are the projections from the Ericsson Consumer Lab. The mobile traffic data per active smartphone goes up to 4.5 gigs from 1 gig, what we saw in 2014. And we see that the total smartphone traffic starts hitting 2,500 petabytes, which is about 22-fold in 2020. And this massive shift of increasing data, so we are rapidly becoming a society which was voice-centric to data-centric. Now, it is important to note that a large part of that data is actually consumed indoors. We spend 90% of our time indoors as consumers, and the total traffic, as we see in the network, 70% of that originates from indoors as today. But the dichotomy of the situation is such that only 4 in 10 users, that's 40%, are overall satisfied. So look at the situation again: 90% time spent indoors, 70% of traffic originating from indoors, and only 40% satisfied users from indoor cellular connectivity experience. That's the problem we're trying to address. That's what we need to do to make sure that Indian consumer is satisfied for the use they have for smartphones, which is mostly indoors. If I go to the next slide then, so why cellular for indoor? Because we already have prevailing technologies such as Wi-Fi, but we believe that alone is not sufficient. The demand of subscribers to continue to use cellular mobility in India is quite evident. As evident from what I've shown previously. Why is Wi-Fi not alone in technology today? But as we go more data centric and as we go on applications, we don't want to lose the connection when we move from one floor to another floor, or possibly from indoor to outdoor. Hence the need of complementing Wi-Fi with the cellular mobility. If I then move on, this chart portrays the indoor battlefield. As I said, we're moving from a society that was largely voice-centric to a society that is data-centric now. And while we do that, indoor starts becoming important. We've talked about that. Now, traditionally, this space has been addressed with Wi-Fi. Cellular operators have tried to address this space with traditional DAS systems, distributed antenna systems as well. They've done well in terms of covering at least the marquee enterprise buildings, at least in big cities. They've done quite well by using what we call as indoor DAS. And but when we move to a data-centric world, that starts to show its limitations as well. And that's where we see that the outdoor macro equipment which was being used to blast indoors is also not proving to be sufficient. That's where we need very specialized solutions that offer cellular connectivity, data-centric cellular connectivity indoors as well. And I'll talk through a few of those solutions in a few minutes here as well. This is a slide that exemplifies the challenge a little bit more deeply. Indoor app coverage, we've talked about that. What sort of accentuates the challenge is that we are talking about not just covering indoors with a single technology, but possibly more than two, 3G, 4G, TDD, FDD. We're talking about spectrum bands that are multiple in number. Any of those technologies could be covered in two bands, like 3G on 2100 and 900 and so on. What that creates is that the devices are also then the configuration of devices gets a little bit complicated as well, because you can't force the users to use the device that works indoors on a specific band. Users will use the device that they prefer. And then all of that has to be done in a very cost-efficient way, which means that we need to make sure not only the cost of the equipment, but the installation, the backhaul, the right of way, all of that is managed within a cost that actually lets the business case positive for operators. So from a technical customer perspective, outside in coverage from macro is not enough. There is generally low bandwidth and poor coverage and causes a lot of dead zones, which is basically where the signal to noise ratio is extremely pathetic. How do you cover that? But before I get there, here's an example of a city where the voice and text messaging coverage is depicted. What you see is if I then move to let's say this is the app coverage for HD video streaming. Then if we try and do some additional densification, use the latest software, use features which avoid interference, then we go back to an HD video streaming for app cover for this app going back to 100%. But this is an immensely low traffic scenario. We've basically created a network for HD video streaming, which is mostly not utilized. Then, if we actually look at traffic going up, which it will, because the network is created to capture that, we see that we start moving back to an app coverage, which is actually not healthy at all. We start moving to an app coverage which 1 out of 5 users get reasonable app coverage on HD video streaming. And then, what do you do then? It's very important. Then we look at specific areas and not look at a city or a town in a holistic way. We start looking at topographies such as urban, topographies such as suburban, semi-suburban, rural. But let's, for the purpose of this session, focus on the high dense, super dense enterprise commercial topography. You will see that most of these buildings, even though there is enough macro coverage, don't get what we call as app coverage for indoor. Then we start adding small cells, and then we start adding indoor focused solutions, which means that we are saying let's not cover this topography from blasting from outdoors. Let's start covering this topography by covering them from indoors. Take an inside-out approach on getting app coverage for the consumers who spend 90% of the times inside these buildings and use 70% of the traffic inside these buildings. So that's the purpose of the session. Now, if I go to the next slide, like I said, a lot of these buildings, the largest venues have been already covered with the distributed antenna systems, but those are mostly voice-centric. We need to start covering the other buildings, which are maybe not the largest buildings, such as stadiums or such as airports. We need to start covering other buildings, such as schools, such as offices, such as enterprise buildings, and that is where we come to solutions which are focused on indoor only. And we have built a few solutions. On the chart, you will see two circles. On the right side, you will see a circle which depicts what we call as the Ericsson radio dot system. And the key here is to build a product which is easily installable, which is easily integratable with the existing infrastructure of a building. And when we do that, and then we're not blasting from outdoors, but we're building an infrastructure that is an extension of outdoors to indoors, we see 5x increase in throughput. This is what we have seen globally. 5x increase in throughput as soon as we start covering a building indoors. That's the latent pent-up demand that the building had that was not being addressed. And suddenly now as we go indoors, it starts getting addressed. So the two solutions I want to talk a little bit more about today, and this basically address the very end of the graph, which is higher dense topography. One is the Ericsson radio dot system. The other one is what we call as the picocell. We call it the radio base station 6402. The Ericsson radio dot system is basically used to cover broader buildings such as malls, such as possibly even stadiums and airports. The building size can be vast. It's basically a product that uses very similar technology as outdoors, the same capacity as well, and then we are using floor-wise distribution of these dots around the building. The other one is the picocell, and I'll give you a little bit more detail on both as well in a few minutes. Picocell is simply a pizza box solution where we can extend not only the coverage but the capacity of the outdoor to indoor. It's a product that carries multiple technologies. Today we support LTE, TDD, FDD, wideband CDMA, Wi-Fi, and also what we call as LAA, license assist access, on the same product that is no bigger than actually your laptop. So I'll give you a few real-world examples now. Here's an example from Puerto Rico. This is an operator called Claro, and they wanted to cover one of the buildings in Puerto Rico, which was basically being populated by a bank. And they started using radio dot systems around that building. It was a fairly large building. And what we started seeing is that as soon as we started deploying indoors, the users were able to achieve throughputs of 66 Mbps, which was previously far less than what they had. So the consumer experience suddenly improved dramatically, and they had, at the end of the day, a very, very satisfied enterprise customer. Another example is in the Middle East. Here a mall was covered. Very simple, very similar solution. We started deploying the Ericsson radio dot system, and they saw an increase in download speed by 133%. And finally, an example from Europe. This was a 5-star resort. Basically, the radio dot system was deployed indoors 4 weeks from survey to on air. For those who have deployed or worked with cellular systems and traditionally mostly outdoor systems, we know that 4 weeks is practically nothing. Months are spent just to acquire sites, build sites, deploy them, and integrate them. So 4 weeks for an entire system to become operational was quite good. And now it is providing premium cellular experience to the guests of that five-star resort in Europe. The question that of course comes to mind is, were these buildings not previously covered with Wi-Fi? And the answer is yes. But as I had previously noted, Wi-Fi alone was not sufficient to address the demand. Consumers really wanted an extension of their outdoor experience indoor. They wanted seamless mobility. There was a lot of concern, at least in the first case, about security as well. And those were met by deploying a secure, easy to install, ready to integrate extension of the outdoor by using the radio dot system. Now, those two solutions I've talked about, the radio dot system and the Pico, are definitely products that we promote in the Indian market as well. We launched the radio dot system in September of 2014, and today we have more than 100 customers buying that actively from us globally. The Pico was launched a little bit later, and we had the first installation in early 2015. It's being deployed generally in multiple operators across the world and in India. But then, is it sufficient to get the right hardware products in there? And the answer is no. We need to also complement with the right software and the right processing. So what does that mean? The outdoor adaptation of the software to indoor requirements is also required, which means if I start looking from left to right, processing speeds which can complement Wi-Fi, because at no point would you compromise on your download speeds if Wi-Fi is better. So it has to be better, equal or better in terms of cellular mobility. Now, what cellular mobility offers is much better uplink data speeds, especially as we move to higher generations of technology. Equally important that as we deploy these cells, we put software in there, which means we put features such as discontinuous receive, discontinuous transmit, and so on, which brings greater efficiency in terms of energy. Finally, what is very important, and especially will become increasingly important in India, is that we start using spectrum resources which are just not licensed but also unlicensed. In this case, I mentioned that our product is ready for license assist access, which means that we can offer LTE in unlicensed 5 gigahertz band. This is where Wi-Fi is operational today. So basically, we have put software and algorithms which allows us not to interfere with Wi-Fi and at the same time offer LTE extension on 5 gigahertz, which is quite a wide band. So suddenly, we're getting LTE speeds multiplied by the band size indoor by a product that is, like I said, no bigger than a laptop. If I go to the next slide now. So basically, I've talked about indoor being important. I've talked about how to address the indoor and not do it by actually blasting from outdoor, provide solutions which are catering to this. But it is equally important that while we build indoors, we outdoor macro coverage. Because a lot of solutions in the market today they are basically interfering with your outdoor coverage. And especially in technologies like 3G, this is generally not recommended because 3G is an interference limited technology. So what do? What we need to do is we need to make solutions which are exactly the same in terms of algorithmic coverage, which actually are coordinated between indoor and outdoor. They fully reuse the device chip integration with 3GPP solutions. And this allows basically a seamless indoor-outdoor working. As you step into a building or out of one, you don't notice a drop, a dip, or a burn. It is basically an extension of outdoor into indoor. And there are no interference caused between indoor and outdoor because having two disparate systems. It's basically an extension. Very important to note. It also helps in case of offering voice over IP by getting the right regulatory compliance and so on and so forth. If I go to the next slide. Now, many of you may have heard of the term carrier aggregation. It's quite popular in countries with more spectrum or delivery of cellular through technology called carrier aggregation. Basically, the technology enables you to get higher peak bit rates by combining one channel or one carrier with another when they're not adjacent. For example, you can combine carriers in 1800 megahertz and let's say 2300 megahertz and produce a system that offers much better peak bit rates, and so on and so forth. Now, why do I talk about it in this session? I do talk about it in this session is because you will require carrier aggregation not just for macro, but also for indoor. It is very, very important because if most of the traffic is being used indoors, as soon as we will put these indoor solutions that I've talked about in the earlier slides from a hardware and software perspective, they will be used up. How do you get to the next level of capacity? This is where you use carrier aggregation. And already compliant for carrier aggregation. The Pico supports aggregation of 2 bands even today. It offers carrier aggregation even with the LTA, which is basically LAA and 5 gigahertz. And the graph on the right will actually show to you the amount of improvement. This is from Korea. This is a few years ago. Of course, Korea has since moved to 3 carrier aggregation as well. But I'll limit my excitement to 2 carrier aggregation in India for the moment as more spectrum gets auctioned. Here you will see that the throughput improvement is considerable. This is a CDF, and you will see the throughput improvements go up significantly as you aggregate more than one carrier. What it also does, it provides an indoor capacity and very, very good app coverage. That means that let's say you have one band which is 1800, another band that 2300. Suddenly on 2300 you start getting coverage which is on 1800. That means you can use the uplink of the lower band as a complement to the downlink of the upper band. You get a bigger cell and a higher throughput. Another very important piece of technology which is called combined cell. Basically, this means that since I'm using the same baseband or the processing or the brain, I can actually combine multiple single carrier cells and basically reduce interference because the transmission on one cell is coordinated or aggregated across many sectors, single carrier sectors. It increases the data capacity and it increases the throughput, and you have indoor and outdoor built similarly and on the same baseband technology. I've already mentioned LTU, which is unlicensed spectrum. I sincerely believe that this will be a technology that will really change the landscape of mobile broadband indoors in India. We are a country which has some spectrum limitations per capita. We addressed by offering unlicensed spectrum to boost the speeds. And 5 gigahertz is an extremely good band to do that. It is relatively interference free, and we have built technologies to actually avoid conflicts with Wi-Fi transmissions already. We sense Wi-Fi and avoid it, and this can complement the outdoor LTE coverage magnificently. One of my last slides, when you build indoors, a lot of times we are asked, if you're going to deploy a solution for, let's say, operator X, can you deploy a solution that works across operators? And the answer is yes. We can actually deploy these solutions which are multi-operator so that you don't have to build a radio more than once. And this is by actually wiring the building right and offering the right bands on the dot. This, what it does, it can offer what we call as shared RAN indoors by actually using differentiation in the core network. So one of my final slides, basically Indian market really calling for a better connectivity, demand is growing, indoor is the next landscape, the next addressable market. There is huge pent-up demand. As I said before, where we have deployed these solutions, we've seen 5x improvement in demand. And that we believe India requires as well. And these solutions are today generally available for practically every size and type of building that we can use in India. So with that, I want to close my presentation here and open the floor for questions.
Thanks, Mr. Batra, for a great talk. We have shared a couple of questions with you.
Yeah, I'm reading through that. I'm going to just read them aloud for everyone. I've heard that across world operators with network OEM are also experimenting with IoT-based devices on LoRa open spectrum network to improve voice and data coverage. Can you shed some light on that, please? Absolutely, I can. Let me first not just mention talk about LoRa, but I would like to talk about IoT in general. We feel that we want to build networks today which are IoT, and not just consumer IoT, but industrial IoT compliant, which means that the cellular technology that we are rolling out should not only be for today, but for 5G compliance as well. And what we have started building is basically called low power wide area cellular technology, which means we have started building LT for IoT. It is basically a technology that allows for offering LT on extremely low bandwidths, and this is basically focused on IoT. We've also started deploying technologies on GSM, which we call as GSM for IoT, and this of course starts using the existing networks. We can just software upgrade them, and these can be used for IoT specific applications as well by using minimal amount of spectrum or bandwidth available. And that is the challenge, because the IoT devices are going to be many more in number than number of subscribers we have today, and we cannot really use all that capacity just for IoT. So then you have to start using spectral algorithms which allow you to capture this traffic on minimal spectrum usage, on minimal bandwidth. So two technologies we have come out with, basically on cellular, GSM for IoT, and what we call as LTE, and basically for machine to machine, where there is a latency requirement in addition to coverage, we propose LTE-M. Otherwise, we basically say GSM for IoT. And both of these offer two critical important features. One is extremely high spectral efficiency for IoT. Two, extremely good battery life for IoT, because when we put the sensors out, you're not going to touch them or replace them for multiple years. So those two we have done, is generally available. We are actually deploying networks today. We're actually deploying networks which are capable of doing this for next decade, I would say. That's the level of, that's the level of processing power we're putting in our systems today. The second question about the same individual. There were news on POC for Wi-Fi, LED-based Wi-Fi. What do you see? Absolutely. I mean, it's a technology we have to keep an eye out for. We have to make sure that it can be commercially delivered. It has shown initial promise, and our advanced technology labs are looking at it we're very interested and continue to look at it. Do I see it as a major future technology? I think it's a little bit early to mention that. I think we have to look at, although it seems promising, the commercial viability has to be established in a little more detailed way. I'll move on to the next question. With the increase in 4G services, now we'll see a lot of call drops. How are you going to manage that? So, Aditya, there are multiple ways to skin the cat, right? How do you manage call drops? I think that is essentially a multi-billion dollar question in India today that everybody's asking. I will answer that from a technology perspective, not from an investment perspective. That is not my job or what we do at Ericsson. From a technology perspective, you have to increase coverage and capacity. How do you do that? You add more sites. That means sites have to be available. Or you actually sectorize the sites, which means that you split sectors on a site. You go from 3 to 4 to 5 to 6 sectors on a single site. You add spectrum, which means you add channels or carriers, which increases capacity, and in some cases, if you get a low spectrum, you also get coverage. That's a possibility as well. And what I talked about today, you add solutions which actually fit the topography. You don't start putting macro cell sites everywhere. You start putting solutions which are focused on indoor topography, the ones I talked about in this session today. You start putting solutions which are built for rural topography, which are low power solutions, low power input solutions. So Again, I think it's a very good question. From a technology perspective, we have to continually increase capacity and coverage. You do that by adding sites, you do that by splitting sectors, by adding carriers, by improving the transport network, by putting solutions where they are fit, indoor for indoor, rural for rural, and that is very important. So that's my answer with it. And now, of course, there's a question of investment behind it, and I'll let the operators decide where and when to invest and manage that. I will move to the next question. What's my view on TV white spaces, and what is Ericsson doing in this area? It's an interesting technology, white spaces. You can use spectrum which is not being currently used. But I will say, Anshuman, my view is that you have to look at it one level deeper. Can you leave spectrum unused, or can you actually use it properly and commercially? My biggest concern with that technology, especially for a country like India, my friend, is that if I have the spectrum which is called white spaces and anybody can come and use it, it'll be used the most inefficiently that it can be. And I can tell you, India does not have spectrum to lose for inefficiency. You would rather use that spectrum, you would rather organize this spectrum and then move it into a more efficient cellular technology that is available today than actually start experimenting with it. That is my view. From a pure technology based, yes, white spaces means that you can do some frequency planning, you can actually jump around carriers, those technologies we have today. But it's important to use that spectrum efficiently, most importantly for a country like India, which has spectrum limitations as per the operator's comments. So that would be my answer to that question. I have one more question come up. 6402 RBS is supporting combined cell feature or not? 6402 RBS supports combined cell feature as long as you are integrating and coordinating with the RISE baseband, and the software has to be deployed accordingly. Did I miss any? I don't think so. I don't see any more questions. I'm talking to the coordinator on the call now. How would you like to proceed? I see one more now. RDS is supporting multi-operator technology, multi-vendor. No, it's not multi-vendor. RDS is an Ericsson technology only, and it is we are supporting multi-operator technology today. Yes, absolutely we are, and I depicted it on the last slide today as well. We are moving towards multi-operator technology. We're going to generally available that very, very soon. Question from Vishal. In India, there are major areas of low bandwidth. So, what is the future for IoT technology-based network? Many of us have one plan for it all the time. Trying to understand. Yeah. So, you're talking about areas with low coverage, and for IoT? I think it is important to understand that you would need some coverage to get IoT coverage as well. And that's why what we are suggesting is to look at technologies such as LTE-M and GSM for IoT, which are extremely spectral efficient and can actually be. So let's say we have a low band, then you can actually deploy a low band for IoT, which covers massive amount of area, or actually landmass, because we were covering areas which is not just generally highly populated, but also for IoT applications, as you very well mentioned, and use little bit of that spectrum to deliver only IoT, is what we foresee as the future for IoT technologies in terms of cellular. like I said, you will not have to build for massive capacity. You will have to build for low capacity, high latency, low capacity, low latency, and high coverage. Okay. In case there are no more questions, then I'd like to thank you all. I think from our perspective, this is extremely important area. We continue to invest massively at Ericsson to cover what we call as the next landscape for mobility, that is indoor. Uh, we plan to continue to come out with hardware and software solutions to be able to address the space. A lot of good discussion and questions on IoT. This is one of the most for us as well, and we will continue to invest in this area actively as well. And we will keep the market and you guys apprised in upcoming discussions, possibly webinars and other fora. So I thank you all for attending and hope to connect again. Thank you.